Hello, Dr. K. Please let me explain my homework 5.1. It's from Labview. Okay, so let's begin. The title of this research is Multi-Channel Digital Output Control System. So the content of this research, firstly, is purpose, and the second one is content, and the third one is hardware connection, and then is implementation process, and Labview connection diagrams, and summary. So the core objective is implement a monitor channel digital output control system, and using Labview and shift operations. And the goals of this learning, we should learn to master core concepts of digital 10, then deeply understand engineering application of shift operation, and learn and practice data serialization and serial parallel conversion. Then build complete capabilities in software, hardware, design. Last one is understand the paradigm of visual programming. So shift algorithm logic design, selection and implementation of shift models, state update machine using shift registers, and timing and control with wait function. Then the second part is Labview and hardware interface, configuration of digital output channels with DAQ MX, data format, matching, and resources management. Then the user interaction and the control design. Front panel design, intuitive UI with LED indicators, control buttons, and a speed curve. Event driven programming, implement interaction between the user interface and the background loops, change shift direction on button press. The third part is hardware connection. You can see the picture. We need LED array via connection wires. We should resistor calculation using loss to prevent excessive currently. So we can see the how to get the value of this resistor. Then we circle for a complete current loop. Without it, the circuit will not work. So the implementation process. The path one is front panel design, user interface. Place 8 LED indicators, LED 0 to LED 7, in a row, and add control elements, start stop button, shift direction switch, speed control knob, and optimize layout for intuitive and processional interaction. Then we should know the implementation process. Pass 2, block diagram design. We create task, define virtual channels and start the task. Main loop structure using a while loop controlled by the start-stop switch. Implement shift logic. Use a shift register. Select function and logic shift function. Write to hardware using this one write function and update LED indicator. Then control of speed using the wait function connected to speed knob. How to connection in Labview with the core shift logic. Shift register stores the current 8-bit LED state. Select function. Choose left or right shift based on user input. Then logic shift function. Perform the actual bit shift. And DAQ MX right. Send a new state to the hardware. And wait function is controls the loop speed and thus the animation speed. Schematic 2 is front panel layout. 8 circular LED indicators arranged horizontally for real-time status, and the speed control knob adjusts the shifting animation speed, and start-stop toggle switch. Start or stop the program execution, and the direction selected a button. Switch between left and right shift. Then is task management. Okay, the summary. This project integrates Labview programming, shift operational principles, and hardware control to implement a multi-channel digital output system. The key learning is digital window control fundamentals. The second one is practical application of shift operational. The third one is software hardware integration workflow. The fourth one is Labview usage and resources management. The last one is user interaction and event driven design. Okay, thank you very much.